This is about the introduction to the organic chemistry. So a different homologous series, different functional groups, how to name them, how to write the formula, how to write the structure. It's all about that. We'll start with three alkanes, alkenes, and alkynes. All three are hydrocarbons. Alkanes will have carbon-carbon single bond. Alkenes have carbon-carbon double bond. Alkynes will have carbon-carbon triple bond. General formula of alkane CnH2n plus 2, alkene CnH2n, alkyne CnH2n minus 2. So as the single bond becomes double, double becomes triple, two hydrogens are removed. So two hydrogens become less. These two are unsaturated hydrocarbons, and this is alkanes are saturated hydrocarbons. Functional group, alkane has no functional group. Alkene mein functional group is this carbon double bond carbon. So this part is the functional group, which is called as alkenyl. Okay, you can remember the word alkene. The E is replaced by YL. Similarly, the functional group in alkyne is alkynyl. So the word alkyne and E is replaced by YL. Okay, that's about alkenes, and alkynes. Now the naming, if there is a alkane with 4 carbon atoms, it will be butane. But stands for 4 carbons. Ane, that's a suffix for all the alkanes. Alkenes may butene, but here there will be isomers because if there are 4 carbons, then I have to put a double bond there. The two possible positions for the double bond at carbon number 1 and double bond at carbon number 2. So this is but1ene and this is but2ene. Similarly, if there is alkyne with 4 carbon atoms, again there are two possible positions for the triple bond to be. So if there are 4 carbon atoms, triple bond could be at carbon number 1 or triple bond could be at carbon number 2. So this is but1 ine and but2 ine. Okay, so that's all about alkanes, and the naming, general formula, etc. Next two homologous series will be alcohol and ether. Alcohol has a carbon chain. This carbon chain of 2 carbon atoms and OH bonded to that. Now this is the alkyl group. And this is the functional group. Alkyl group is variable, like this is 2 carbon, it could be 3 carbons also, 4 carbons also, 1 carbon also. In general, the alkyl group ka formula, general formula is CnH2n plus 1. So if there are 1 carbon, there is 1 carbon, H3. C2, 2 carbons है तो H5. C3 है तो H7 and so on. And OH as the functional group. So this is alcohol with 1 carbon, alcohol with 2 carbons, 3 carbons, etc. Functional group name is hydroxyl and not hydroxide. It's hydroxyl. General formula CnH2n plus 1. This is alkyl group. And OH, which is functional group. That's the general formula. Naming. The general name is alkanol. So if one carbon, then this prefix will change to meth, enol, methanol. If the two carbons, then prefix will change to eth, enol, ethanol, and propanol, and so on. That's about alcohol. Ethers will have O, oxygen in the middle, and there'll be both the sides, there will be a carbon chain. So there can be a carbon chain, there will be a carbon chain on the left hand side and the right hand side. So O will be in the center. The general naming of ether is alkoxy alkane, where the alk and the alk, ALK, are the prefixes of the two alkyl groups on the left and the right hand side. But which alkyl groups comes where? The shorter chain between the two will be the first word, alkoxy. So which means that if there is two carbons ka chain on the right hand side, alkyl group of two carbon atoms, which is here. And left hand side means there is an alkyl group of only one carbon atom, which is a shorter chain. So because this is only one carbon atom and this is two carbon atoms, first word may this will be the shorter chain, which means meth, oxy. And this is two carbon atoms, so eth, ane. So methoxy, ethane is the ester. Similarly, if suppose there is C3H7 here and C2H5 here. This is shorter chain, this is longer chain. Two carbons and three carbons. So this will come the first word. So ethoxy propane. Name of the functional group is alkoxy, which is this. Alkoxy is the name of the functional group of ether. So that's all about the naming and the structure, etc., of alcohol and ether. In alcohol, you have primary, secondary, tertiary, which we will do a little later. Next is aldehyde and ketone. Both of them have carbonyl group. The difference is that in aldehyde, carbonyl is bonded to hydrogen on one side. Other side may be hydrogen, may be an alkyl group. R is the alkyl group. Ketone may both sides must be alkyl group. I'm writing R dash here because the length of the two alkyl groups or the number of carbon atoms in each alkyl group may be different. So if I have aldehyde with four carbon atoms, then one carbon atom is this in the functional group itself. Functional group of aldehyde is this, and functional group of ketone is this. Now, if I have aldehyde with four carbon atoms, so one carbon is already here. In the alkyl group, there will be three carbon atoms. So there will be a chain of three carbon atoms, and the fourth carbon atom will be the aldehyde. Here, if there are four carbon atoms, one carbon atom is already here. There are three carbon atoms left. So I can have two here, or one here, or two here, and one here. It doesn't matter. Okay. Anyways, naming of that we'll see in some time. Let's come to aldehyde. If it's a aldehyde of four carbon atom, matlab but. So butanol is the name. In general, the name is alkanol. The functional group of both are called as alkoxy. Sorry, not alkoxy. This is carbonyl. Both are called as carbonyl. C double bond O. Naming of ketone. 4 carbon atoms agar hai. So I have C double bond O surely in this. So I have 3 carbons left. So 1 carbon is already here, 3 more carbons. I can have 2 on the left, 1 on the right, or 2 on the right, 1 on the left. Doesn't matter. Naming doesn't depend on the shorter and the longer chain on this side. I have to consider all the total number of carbon atoms. So there are 4 carbon atoms. So butanone. In general, the name is alkanone, where ALK being the prefix. Will vary depending on the number of carbon atoms. Okay, so that's about the aldehydes and the ketones. In the molecular formula, identifying the aldehyde is it will have CHO in the formula. So suppose there is CH3, CH2, CHO. If CHO comes, that means that's aldehyde. And ketone will have CO somewhere in between and the carbon chains on both the sides. Okay. CO somewhere in between. This is carbonyl and these are the two chains on its two sides. So here the name will be 1, 2, 3, 4, 5, 6. So hexanone. And this will be propanol. Next two homologous series are carboxylic acid and esters. Both have C double bond O, single bond O. This part is common. In acid, the singly bonded oxygen here has to be bonded to hydrogen only. That makes the functional group of COOH, which is carboxyl. And here there is an alkyl group, the carbon chain. Ester, there has to be an alkyl group here, not hydrogen. And here this could be hydrogen or alkyl group. Here also this could be hydrogen or alkyl group in the carboxylic acid. Okay. So in carboxylic acid ka functional group is carboxyl. Naming, if there is a carboxylic acid with 4 carbon atoms. So just may say 1 carbon atom is in the functional group itself, which is carboxyl. So the functional group has to be there. This has to be there in every acid. Now this is a carboxylic acid with 4 carbon atoms. So I have to draw 3 more carbon atoms behind this in the alkyl group. So total 4. This is butanoic acid. This is butanoic acid. Okay. Functional group carboxyl and that's it. Now, iska in the ester, there is C double bond O and C single bond O. And there are R's on both the sides. Both may have a different length, but the name doesn't depend on the length. The general name is alkyl alkanoate. Is alkyl alkanoate. So, which alkyl is which one? Like this, there is an alkyl here, there is an alkyl group. So, which alkyl is which one? The alkyl which is bonded to O, this is always the first word. And this alkyl, along with this carbon, is the second word. For example, if the ester is this. So in this, the singly bonded O, the alkyl bonded to that is this, which is methyl. So this will be the first word. 1 carbon is liye methyl. Okay, as in alkyl. And the second word will be these carbons, including the carbon in this. There's 3 carbons here. So that's propanoate. Okay, so that's methyl propanoic. Okay. Another way to look at this is that the carboxylic acid, any carboxylic acid, suppose this is butanoic acid again. This is acid, which means this will donate a proton. Okay, so this H is the proton which is donated always. H from the COOH. Now what is left here is a negative ion of the butanoic acid. So this will not be called as butanoic acid. This negative ion will be called as butanoate. This negative ion will be called as butanoate. Similarly, here we have propanoate in the same line. So propanoate comes from propanoic acid, which has lost the hydrogen, the proton. So if I have to draw propanoate, only the propanoate, I will draw acid with 3 carbon atoms. Third carbon pe COOH. This is propanoic acid. And as I said, if I remove the last ka H, this becomes propanoate. Like how butanoic acid became butanoate here, propanoic acid became propanoate. That's propanoate. Now methyl, if I have to draw, which is 1 carbon. So just 1 carbon here, methyl. So methyl propanoate. This is the name of the ester. So in the general formula, like molecule that you write, it is COO. COO will be there. If there is H here, that means this is acid. If there is a carbon chain here, matlab this is an ester. Okay, CO के बाद में there is a carbon chain, matlab ester. CO के बाद में there is H, matlab this is an acid. Okay, so that's about ester and the carboxylic acids. Now the next are the amines and the amides. In amine, you can imagine ammonia, in which there are hydrogen atoms. So if one of the hydrogen atom is replaced by an alkyl group, the carbon chain, this becomes amine. This is the functional group of amine, which is called as amino. Yeah, okay. In the ester, I forgot to mention the functional group. So this is called as ester only. There's an alkyl group here, alkyl group here. This is the functional group of ester, which is the name is ester. Functional group name is also ester. So amine ka functional group is amino, which is NH2. Name depends on how many carbon atoms. So suppose this is 3 carbon atoms there. So this is propanamine. That's amine. Amide, again, imagine that it is ammonia, but one of the hydrogen is replaced by carbonyl group. If it is replaced by carbonyl group, this becomes amide. And this becomes the functional group of amide, which is called as amido. That's amino. That's amido. Okay. Naming depends on how many carbons here and total number of carbons. So if this is 2 carbons here and this is the third carbon, so a chain of 2 carbons, third carbon pe there is carbonyl bonded to NH2. This will be propanamide. Propanamide. Propanamine. Next, halogenoalkane. As the word suggests, there is an alkane in which there is a halogen. So if there is a propane, 3 carbons, and if there is bromine here, this is bromopropane, this is halogenoalkane. The functional group is here is halo. Okay, halo can be specific, like agar this is bromine, तो ब्रोमो, क्लोरीन है तो क्लोरो, आयोडीन है तो आयोडो, एंड फ्लोरीन है तो फ्लोरो. The functional group could be specific. So bromo functional group, chloro functional group, etc. That's halogenoalkane. Next is phenyls or aryl things. So which are benzene derivatives basically. Benzene में there is 6 carbon atoms. There are 6 carbon atoms in hexagon. and there is an alternate double single, double single, double single bond, which usually we show it as a ring. And it is bonded to 6 hydrogen atom, matlab each carbon atom bonded to 1 hydrogen atom. This is the structure of benzene. In benzene, if I replace any one hydrogen with any atom, other atom or group of atom, suppose I'm writing X here. Now X could be any halogen, X could be an alkyl group, X could be a functional group. Then this part over here, without the X, this becomes C6, H6 की जगह पे this becomes C6H5 because one hydrogen is replaced by X. So this becomes phenyl functional group. Okay. There are very limited benzene compounds that you have in your syllabus, which we'll see in the reactions. So that's all about the halogenoalkanes. Next is primary, secondary, and tertiary carbon atoms and nitrogen atoms. First, we'll talk about carbon atoms. Primary, secondary, tertiary carbon atoms. So primary, secondary, tertiary carbon atoms are actually giving you primary, secondary, tertiary alcohols and primary, secondary, tertiary halogenoalkanes. So we'll take the examples of both. So first example will be of alcohols and then halogenoalkanes. So in short, we need to know what is primary alcohol, secondary alcohol, tertiary alcohol, and primary halogenoalkane, secondary halogenoalkane, and tertiary halogenoalkane. So primary, secondary, and tertiary. The concept is same for both. If it's an alcohol, then primary alcohol is that alcohol in which OH is bonded to that carbon, which is bonded to only one carbon chain in further, matlab one alkyl group. So these two atoms should be hydrogens. In other words, OH must be bonded to the first carbon atom in the chain. OH should be bonded to the first carbon atom in the chain. That's primary alcohol. Secondary alcohol is the one in which OH is bonded to that carbon, which is bonded to further 2 carbon chains. That means the third bond here is hydrogen. So that means only one hydrogen here. So these two are the carbon chains which are bonded to this. That's secondary. Tertiary, OH is bonded to that carbon, which is bonded to further 3 carbon chains. The 3 alkyl groups. In the definition, you can say 3 alkyl groups or 2 alkyl groups or 1 alkyl group. So OH bonded to that carbon, which is further bonded to 3 alkyl groups, is tertiary. Matlab there is no hydrogen here. Okay. That's primary, secondary, tertiary alcohol. Name wise, in the primary alcohol, the name will end with 1 all because OH ka position has to be first. So it could be propane 1 all, which means 3 carbon atoms. OH on carbon number 1, so propane 1 all. Secondary, the position of OH should not be 1. It can be anything. It can be anything 2, 3, 4, whatever, but not 1. For example, propane 2 all. If OH is here, this is propane 2 all. Second carbon, but it can't be in the first carbon. Tertiary may, the OH will not be on the first carbon atom, it will be at the second, third, and whichever carbon atom has OH, that carbon atom will also have a branch. So if there is a 3 carbon atoms, OH is here, this carbon atom will also have a branch. So this is propane 2 all with a methyl branch at carbon number 2. So this will be 2 methyl propane 2 all. So you should see that the position number of OH and position number of alkyl should be same. If the branch is on 2 and OH is on one, that doesn't make it tertiary. The position of the branch and position of the OH must be same. So these are primary, secondary, tertiary carbon atoms. Now, if I replace the OH instead of OH, if I take any halogen, let's say if I'm taking iodine or bromine, let's say, then this is again primary, secondary, and tertiary. The concept is same. The name will be 1 bromopropane. Here will be 2 bromopropane, and here will be, if there is a like bromine here, then 2 methyl, 2 bromopropane. That's about primary, secondary, tertiary carbon atoms. Now about nitrogen atoms. In amines, there are two actually, amine and amide, but your syllabus you have only amines. Primary, secondary, tertiary, which is very easy. You can imagine ammonia. Ammonia mein, these are the hydrogen atoms. If one of the hydrogen atoms is replaced by alkyl group, this is primary amine. If one hydrogen is there but other two are replaced by alkyl group, that is secondary amine. And all three are replaced by alkyl group, it's a tertiary amine. Okay. Now the naming में, if suppose this is methyl, like CH3 अगर है, so methanamine, methane, no. If suppose इसमें this is methyl है and this is also methyl है, that means dimethyl amine. You need to mention all the alkyls. Dimethylamine. Hmm? इसमें suppose this is methyl, and this is ethyl. Eth. Then E comes before M. So ethyl and dimethyl, because there are two methyls. So total three alkyl groups. Amine. Ethyl dimethylamine. Okay, so that's about the naming of the primary, secondary, tertiary nitrogen atoms, which are in amines. One more thing which particularly HL students will find this helpful in the spectroscopy is that alcohols and ethers, they can be isomers because both of them will have the formula, general formula CN H2N plus 2 O. Example C3 H8 O. So now this can be an alcohol with 3 carbon atoms such as propanol, or this can be ether, which could be like methoxyethane. Similarly, aldehyde and ketone have the general formula CnH2nO. For example, C3H6O. So this could be an aldehyde with 3 carbons such as propanol, or this could be ketone with 3 carbons like propanol and propanone. Similarly, the carboxylic acid and esters can also be isomers. General formula being CnH2nO2. So for example, if this is C3H6O2, this could be an acid with 3 carbon atom, which is propanoic acid, or this could be ester with 3 carbons. It could be methyl ethanoate or ethyl methanoate. Okay. So remember this pairs: alcohol ethers, aldehyde ketones, acid esters. Remember the general formula also for this. Okay. So that's all about the introduction to the different homologous series